looking at isosceles and equilateral triangles. First, we're looking at isosceles triangles. Remember that isosceles triangles have two congruent sides, and those congruent sides are the legs of your triangle. So, in the picture down here, the ones with the tick marks are our legs. The angle that is being made by those two legs is the vertex angle. That means in our picture that angle 3 is the vertex angle. The side across from, or opposite, that vertex angle is called your base. And the two angles that are on that base are called base angles. And there's something special we know about our base angles. Our base angles are congruent. So we know angle 1 is congruent to angle 2. We still know that each of the legs are congruent. That means that the base is not congruent to the legs, and angle 3 is not congruent to the other two angles. Next up, when you have an isosceles triangle, so you know that segment AB is congruent to segment AC, then you also know that angle B is congruent to angle C. Your two base angles are congruent. You know that the converse of this is true as well. If you have your base angles of a triangle are congruent, then you know that the sides across from them are also congruent. That segment DE is congruent to segment DF, which means that it's an isosceles triangle. So our next set of examples, we want to find each angle measure. We have what kind of triangle? An isosceles. And we are looking at angles because these have degree measures. Now, we have the vertex angle, and we have one of the base angles, which means that the other base angle is the same as the base angle we were given. It is also x. Now this is still a triangle. Angles in a triangle still add up to 180 degrees. So that's what we're going to do. We are going to add what we have and set it equal to 180. Combine your like terms. 2x plus 38 equals 180. Subtract 38 from both sides. And we have 2x equals 142. Divide by 2 on both sides. And that gives us that x equals 71. And since x was what we put for our angle C, that means that the measure of angle C is 71 degrees. On our next triangle, we have two sides marked as congruent. That means that this is an isosceles triangle. and we have things with degree measures. So we are looking at angles. And angle T is our vertex angle. That makes these two angles base angles. And we know base angles are congruent. So we can set 2x equal 2x plus 30. Subtract x from both sides. So we'd have x equals 30. But we want to find the measure of angle S. And angle S was 2x. So we need to substitute that 30 in for x. 2 times 30. And that equals 60 degrees for the measure of angle S. Next up, we are looking at equilateral and angular triangles. This says that if you have an equilateral triangle, meaning that all of your sides are congruent, then you know you have an angular triangle, meaning that each of your angles equals 60 degrees. The next one is the converse of that, and it says that if you have an angular triangle, meaning you have each of those angles being equal to 60 degrees, then you know that all of your sides are congruent. On our next set of examples, we want to find each value. We have a triangle with 3 congruent sides. We know it's an equilateral triangle. And we are given information that has a degree sign by it. So again, we are looking at angles. And what do we know about angles in an equilateral triangle? Each one equals 60 degrees. So this angle equals 60 degrees. 3x plus 15 equals 60. This only works for equilateral and equiangular triangles when you are looking at angle measures. Make sure that you see a degree sign. That lets you know that you're looking at an angle. Then we can solve. Subtract 15 from both sides. (3x equals 45). Divide by 3. And x equals 15. Next up, we have an angle with 3, we have a triangle with 3 angles marked as congruent. This means we have an equiangular triangle. Then we're going to look at the information we're given. It has no degrees. That means we're looking at sides. And what do we know about sides of an equiangular triangle? We know that they are congruent. That means we can set these equal to each other. So 4t minus 8 equals 2t plus 1. Subtract 2t from both sides. So we have 2t minus 8 equals 1. Add 8 to both sides. And 2t equals 9. Then we can divide by 2. So t equals 9/2. Next one is a review from yesterday. We want to find the measure of angle A. We have an exterior angle from a triangle, and we have 2 remote interior angles. Remember that we take our exterior angle 124, and it equals our two remote interior angles added together. So 124 equals 10x minus 5 plus 8x plus 3. Combine our like terms. So 124 equals 18x plus 2. No, not plus 2. Minus 2. Add 2 to both sides. 126 equals 18x. And 126 divided by 18, which gives us that x equals 7. But we're not finished because we're looking for the measure of angle A. And angle A was 10x minus 5, and we need a substitute. So 10 times 7 minus 5, 10 times 7 is 70, minus 5 is 65. So the measure of angle A equals 65 degrees.